Hey, good evening. Thank you so much for the invite. My name is Vishnu. I work with the ITU focus group for machine learning. Um, when I was preparing this presentation, we wanted to give you an overview about what we have done in the last 2 years in this space. Essentially, we have tried to build a framework which applies the machine learning concepts. So in the last 2 days or so, what you heard, the question is how do we apply this in the context of 5G networks? So this is the agenda. I will give a background and context behind what we have, why we have done what we have done. There are some use case stories which I will take as example, and then I will tell you about what is the current work which is going on, maybe another 6 months in future, and then there are some missing pieces that we see from our vantage perspective, and there are some opportunities for collaboration if you will. So this is the background and context behind the ML in 5G work. ITUT made this focus group in 2017 November, so more than 2 years back, and this is a child group of study group 13 under ITUT. And we essentially, for the first 2 meetings, we looked at what are the use cases and which can be used in AI ML in 5G. Then we looked at what is the architecture, what kind of framework is required, and then we looked at what are the extensions for some specific problems. I will come to that in a bit, and some applications and outreach. That's why I'm here. And also some gaps about how we see going forward what has to be done. A little bit more about where we stand with respect to solutions. So you see here, these are the kind of networks. For example, there are different types of verticals like 3GPP networks also. These are other SDOs, and there is open source. This consists of what we see as where machine learning can be applied from an ITU perspective. Then we look at interface design towards this, and kind of pipeline overlay with these characteristics. I will talk about this. And then we also see there are researchers like you guys, and also academics, and who can actually use this framework and build some algorithms and machine learning techniques on top. This is our ecosystem picture, as we call it. We have our next meeting coming up in March. That's planned. So first we started with use cases. There were about 30 use cases or more than that, which was submitted to the focus group. It included operators, vendors, and academics, researchers. They came together and they submitted this as contributions to the ITUT focus group, and they were analyzed, and we also looked at what are classified it and so on. So this is how we went about. We classified it into different categories. We derived some requirements from it, and then we classified the requirements. So these are the categories of requirements. This is now published. You can Google it. It is published as supplement 55 as of Y dot series, and this is now we are going back to the drawing board to analyze what are the gaps in adapting this kind of use cases. Are there more? These are the kind of questions that we are trying to answer now. So this is the first learning that we learned from this exercise is that we need to do this continuously. So we have our second call, which will come up. Then I go to the first use case story, if you will. This just a representative example. It is. I'm not going to go through this entire list of use cases, but I want to show you how we came up with and what we learned from these use cases. The first one is machine learning enhanced self-optimization network. This was one of our, what should I say, pet contribution from one of our member operators. And this is how we look at it. So you have these UEs, smartphones, and access networks, core network, management plane on one side, and then the data networks. Then we also split it between control plane and user plane. Basically, this you can see from my ATU Y.3104 specification. This is just a simplified picture from it. So we're trying to overlay machine learning on top of it. The data which we apply or in the use case, which the contribution says to be applied is essentially two types. One is from the access network over here, and another from the core network, which is on the top. From the access network, they are planning to look at the location of the UE, measurement report from the UE, which will tell them how the network looks like from a UE perspective, and the resources allocated for that UE, that is at different layers, at layer 1, layer 2, and so on. From core network perspective, we want to look at the traffic figures from the gateways. I think we saw some of them today. Call records and session records in the core network, and resource allocation in the core network in terms of tunnels and so on. So that is the kind of data which we use. What do we do it with? What do we do with it? So basically, the examples of machine learning output is going to be the network parameters and settings, allocation of resources in the access network, and traffic classification and the tagging using DNN. So the contribution also talks about some ways of what can be applied, what kind of models can be applied. For example, deep learning neural networks can be applied in the user plane to do it. So essentially what we do with it is that what we learn from it is that the 5G basically becomes a machine learning underlay, and we define what we call as a overlay network with the source which takes the data from the underlay, applies the configurations which we come up with using machine learning through the sync which you see here to the underlay network, and you have all these types of machine learning, deep learning models, which algorithms which can be applied plugged in through this machine learning overlay. This is one type basic architecture framework that we use based on what we see from the use case. Just an example. So the first learning that we get from this study, this type of use cases, is that you need this separation between technology specific underlays and machine learning overlays, because in the machine learning space you see a lot of advances. You saw it today. There are many different kinds of techniques which machine learning researchers are coming up with and using it, and maybe tomorrow it will continue. Similarly, for 5G, SDOs are continuing the evolution of it. Beyond 5G networks are coming, and this kind of abstraction and separation will give us flexibility to apply what you come up with tomorrow in tomorrow's network as well. The second type of use case story is about machine learning enhanced network slicing. Network slicing, essentially, just to build on the previous slide, this is your basic framework, and now you have different type of heterogeneous slices, and you have resource management schemes for those slices, which are basically built on top of it. What kind of data and training are we talking about for this particular use case story? We are talking about training using network data in the network, learning relationship between different types of traffic demands, and distributing this trained model in the network, and orchestration is an important functionality. And use of simulated data for training. This is we saw some of this today as well, and also over the last 2 days, if you were attending the workshop and the talks, you must have seen this as well, the use of simulated data and orchestration techniques. What do we do with this kind of data and with this kind of techniques? So we try to predict what is the slice performance is going to be. For example, if you are creating a network slice for autonomous driving or e-health applications or industry 4.0 type of applications, then we would like to know with some amount of probability what is going to be the performance of that slice, what is going to be the latency characteristics, QoS characteristics, and so on. We generate the planning and optimization strategies based on machine learning output, and service design and resource arbitration can be automated. This is another expected output from machine learning to be applied in this case. We also think that different schemes has to be evaluated to maximize the end user satisfaction. I think today we heard in one of the presentations the same thing, that you need to be able to compare different machine learning schemes so that you know what is the benefit which can be derived from each of these. Reinforcement learning, supervised learning, this kind of technique can be applied. So if from an architecture perspective, we think that these network slices and simulated network slices should basically coexist as ML underlays for us. And we also think that there has to be a sandbox which will host trial and error kind of environment where operators can deploy solutions, evaluate it, and then take a decision on what has to be deployed in the real-time network. So this is an important learning for us, that testing environment and possibly with the real data. So you take the data from the overlay and use it for training and evaluation in the sandbox, and based on that evaluation, you deploy the machine learning models in this overlay pipeline. This is one of our techniques. Third one is on traffic classification. Traffic classification, once again, this figure derived from 3111 ITU specification basically shows this kind of service planes, application, service, control, data plane, and resources. This shows the management and orchestration in addition to it, and the machine learning framework. So basically it is similar to what I had shown earlier, but now it is split into different planes. That's all. This figure is essentially the same as what you saw in the previous one. What is new here? So in this use case, we see that monitoring and management is important. You should be able to monitor the capabilities in real time, machine learning capabilities and status of each of these collectors, sources of data, and machine learning models has to be monitored, and some kind of management has to be applied for that. So allocation of resources for even for those machine learning pipeline has to be done based on existing resources in the network at that time, because we are talking about 5G deployments. And then supporting of adaptive machine learning techniques, that is including reinforcement learning and deep learning, and or maybe hybrid techniques. So the output, the expected impact is basically that you have machine learning orchestration in addition to the NFV orchestration that we do already in the network, which includes selection of machine learning models. We heard that in the morning as well. Classification, customization of specific ML model configurations has to be supported, and selection of data. Which type of data has to be applied? Which type of training data has to be applied for what type of machine learning technique? And mix and match, basically mix and match of data, training, retraining, and selection of models. This is what we do for orchestrating machine learning functions. So this is essentially the brain of what we do, and it is controlling the machine learning functions in sandbox, overlay, as well as resource monitoring, which is already done in the underlay. It controls selection training, deployment of ML models, and monitoring and control of this. This is what we call as management and orchestration for ML functions. This is called as ML function orchestrator. That's what you see here. So this kind of what we derived so far from use cases is published as 3172. It's exactly what we saw now, that different underlay networks, ML pipeline, sandbox, and ML function orchestrator. So these underlay networks essentially could be the 3GPP, IMT 2020 as we call it, different types of networks. And the overlay provides an abstraction for us to deploy machine learning. Sandbox, as I told you, allows you to test and verify, and MLFO manages the ML functionality in the network. So this is our complete framework. This integration, it allows integration of machine learning in 5G networks. So just to summarize this current work and missing pieces, in 2019, we analyzed the use cases, we published them, we came up with this architecture framework, we published that, you can Google it and download it, 3172. Currently, this is under ITU review, 3174 for data handling, and intelligence level evaluation framework, that is 3173. These two current work in progress, it is under ITU review. And we are right now scratching our head about how do we take advantage of AI ML advances in 5G, and how do we optimize machine learning models in 5G, and what are the future gaps. So one of the things which we are doing currently is the integration of machine learning marketplaces in future networks. We think that this is an important piece to address some of these plug-in of machine learning in 5G networks, and the ability to choose and select and deploy based on characteristics of data and machine learning. So this is a work in progress. We think that the specific one-trick models that we see now will move to the pattern in including the modeling of which is captured in metadata of the model. So there is two kinds of metadata, one about the data and about the model. So we think that the pattern in machine learning can be captured in the ML model metadata. We think that the standalone models can become a cooperating chain of models that we saw today morning as well. We talked about cascading models. So this kind of cascading is in our framework and our horizon as well. Trained and imported from elsewhere. So this is going to move towards trained in sandbox and deployed in the network with the network data. That's what we see happening. And the current toy networks models like MNIST models, we need to move towards managed, optimized, benchmarked models which operators can use. So for this, we introduce ML marketplace that is with metadata. It's very similar to Acumus that you talked about in the morning. But this one, we are actually talking to Linux Foundation for AI to collaborate with Acumus. Not only with Acumus, we are talking to different operators. We talked to Orange, we talked to China Unicom, Huawei, who all have, we know they have similar solutions. And I will come to that in a bit, but basically the aim is to deploy machine learning models which you guys create with great care and a great amount of research work which goes into it, the linear regression, deep learning models, beautiful models which you create into this marketplace so that we can deploy, test it, deploy it using sandbox and into the network. That's the aim of this marketplace. And the metadata allows us to do it, to select and deploy on a case-by-case basis based on the use cases that I talked about in the beginning. So we think that the metadata is more important for both data and machine learning models. This is now a work item in study group 13 of ITU. You can look at it in 167 document, which I have a list of references at the end. So right now what is happening is that we describe the ML use case in 5G. That is a first step. And then we look at mix and match of data models and ML underlay. We provision ML pipelines in the sandbox, deploy and train in the ML sandbox, compress, distribute and evaluate in the sandbox based on the ITU 3174 that I talked to you, and deploy in the network. This is essentially the number of steps that we see. So data handling framework and intelligence level evaluation is an important part. That's what we enable using the architecture framework. These two, I already told you, 3173 and 3174, this is under ITU review. We are not alone. We work this along with different bodies in liaison. So lessons are all published in the ITU website. For example, we talk to HCGSM for closed loop. We talk to ENI for intelligence level. We talk to Linux Foundation, as I told you, for both for compression as well as for ML Marketplace. We talk to IEC for compression and metadata. We talk to ORAN Alliance for data handling. We talk to ITF NMRG for AI challenge. So that brings me to the challenge part. We are basically trying to understand how to get this research community to engage with us. For this, we plan to conduct ITU AI challenge. This will be a global challenge spread over 9 months in 2020. Aim is to bring participants from all the member countries of ITU. We are planning to have 4 tracks, 2 rounds, 1 conference. Aim is to apply machine learning and validate ITU architecture or any other techniques that you have. Encouraging the use of open source, and we plan to mentor students. Also, ITU runs student projects. I am one of the mentors. We offer university students opportunity to work with ITU experts, and we also have ran a pilot last year, 2019, with 5 countries, and we had 9 contributions, student contributions, which comes out of it. This is a list of references. You don't need to be an ITU member to look at this. There is a color code here. Based on this, you can access with a guest account or with ITU member, or some of these are public documents as well. That's it. Questions?
Thank you. Questions?
I would like to come back to the part on the marketplace proposal you have. My understanding is that today most of the successful ML-based projects have been kind of quite highly vertically integrated. So what do you see will be, because you're proposing the metadata, and Akumos also have such approaches as marketplace. What will be for you some of the enablers or barriers to overcome so that we can have this more modular, more open business model to rely on marketplace for model selection and then the integration for real application? Because today I think there are some barriers to that, not from a technical I would say not from a business perspective, but more from the technical perspective.
Let's see, good question. Good question. So, what we saw when we worked on this, I can tell you about that. We think that current set of stakeholders are interested in what they call as internal marketplace. So they don't want to. They are not yet ready to publish it outside due to different reasons, but that is the case right now. So to address that, we have two levels of marketplace. The one is the internal marketplace and another is external marketplace. That's not our strategy alone. If you look at Acumos, they do the same thing. If you look at AT&T's current deployment of marketplace, is the same thing. So we think that is probably the practical strategy, that they have an internal space where they keep models for employees and internal customers, let's say, to use and reuse. That's one way to do it. And the outside world will see another set of models. This is currently happening. That's one set of challenge. Another challenge which I see is also the ML techniques which we have should be reusable, and we should be able to train. Let me backtrack. They should be generalizable, actually, to come back to the point that Dimitri talked about. They should be, the solutions which we have in the ML space should be generalizable, so that it is possible to at least characterize them with some metadata and use them based on the use case. So our aim is to first have a characteristic of the use case and match it somehow with the characteristics of the metadata. I mean, this is no difference from speed dating, huh? so you basically find a good match. So that's what we are trying to do. But that assumes there is a basic set of generalization which is possible. I don't know whether the ML solutions which we have now are ready for this kind of thing. But just the fact that we have Acumos, just the fact that Huawei is already having an AI solution, just the fact that China Unicom already has a Cube AI, it's already announced, or just the fact that Orange already deployed, just the fact that AT&T already deployed, shows that there is something in it. So yes, there are these kind of challenges, but we do think that with this kind of engagement which we are planning in the next coming months, we can study them more.
I think you are bringing a point where there might be a distinction to be made between experimentation and deployment. And I will give an example. 20 years ago, traffic engineering was one of my topic of investigation. And actually, there were plenty of operators that were ready to cooperate in order to determine which best traffic engineering algorithm would be deployed. But at the end of the day, when it was about sharing about what they would be doing, it was their own, I would say, algorithm and integration, because actually the vendors with whom they were cooperating were able actually to, as Laurent said, to have the primitives that allows them to have also fast processing. And I think that's probably one of the questions that you have to answer compared to that situation. It's going to be the added value of operators to bring machine learning into their network in the way that they believe is the most suited for them. Is it something that you could expect can be shared within the first in the upcoming years? What's your views on that?
Good point. Good point. I think that's a really good question. In fact, that's one of the first few questions that we asked ourselves. Do we need standardization? Do we need interoperability in this case? Because if you have Would we ever reach such a stage where we have models which can be generalized enough to be deployed across networks, and the operators would be willing to share models and reuse all across, and everybody will be happy? It's a happy world. But you know, my point of view in this, and there are people who disagree, I know. But my point is that let us not start with a perfect thing. I don't think so that that is the way to go. I think that we build a plausible, a feasible framework. Okay. Just like what Acumos has done, just like China Unicom has done, AT&T has done, we build a framework. If the players are willing to use it, we are happy. If they are willing to experiment, as you say, we are happy. We are happy to learn from that as well. That's what we are in the current phase. I agree with you that we are in an experimentation phase. We are happy to learn from it. I hope that we reach the solutions mature to such a stage that we are able to just like we do for network functions, we are able to do it for machine learning functions. But I don't know. We may not reach. We have to wait and see. Yeah.
Other questions? I have one about the requirements. So when you analyzed the 30 use cases, I think I've seen requirement for data labeling. So what kind of requirement that you extracted from these use cases with respect to data labeling, for example?
I mean, the requirements, I personally edited that document. I can tell you that it is the requirements and the techniques, machine learning techniques, are no different from what we saw today. The entire of today. Actually, we saw different types of techniques. You talked about it. Laurent talked about it. Dimitri talked about it. We had very nice presentations today. There is nothing in the supplement which is different from what we saw today. The labeling techniques, the classification techniques, the neural networks that we talk about, we have not invented anything new. Okay. So these techniques are still the same, but the intention of documenting it and classifying it and breaking our heads over it is that we are able to. Is it possible to derive some pattern from it? That's the first question. And second question is that is it possible to make a framework which will stay? Which will be adopted, like Dimitri is asking, and Laurent is asking same question. So, is it possible to derive such techniques and frameworks from the requirements? That is that's the major question that we had in front of us. But otherwise, the techniques are still the same. We don't see anything new.
Okay, thank you. Other questions? Then okay, thank you, Ken.